Hi, we're Collider, and we're introducing everyday off-the-shelf manufacturing materials to 3D printing. Imagine you have an idea for a part that could be a new product, improve a process on your factory line, or make something you're already selling even better. You want to test that idea, but standing in your way is the expense of a $10,000 mold and a 4-week lead time for each iteration. Is it any surprise that hardware innovation is moving slower than software? Software development moves fast because you can get immediate real-world feedback, and that means rapid iteration and thus innovation. What if hardware could be as iterative, as adaptable, as agile as software? The current methods for making production quality parts are injection molding and CNCing, which are slow and expensive, and 3D printing, which is faster but makes weaker parts. New entrants carbon and desktop metal are at the cutting edge of 3D printing, driving towards production quality. Collider is part of that continuum, but we're doing something different. We're introducing Orchid, a machine that makes parts in off-the-shelf manufacturing materials. The future of 3D materials choice is here, with plastic, silicone, and rubber. And today, I am thrilled to announce that this machine makes metal parts. We're starting with copper and stainless steel. Let me show you how it works. Orchid is a customized injection molding machine and a full production facility. Orchid's process is so simple. It 3D prints a mold. It injects the mold with off-the-shelf manufacturing materials, and then you dissolve the mold. And in the case of metal, you sinter it in our furnace. The process takes just hours. Imagine having an idea in the morning and testing it in the afternoon in the exact same materials you'd ship to a customer. Think about how much that de-risks your design process. You have a real-world test environment at your facility every single day. Let me show you a video of our patented process in action. We're accessing Collider's proprietary software through a web browser. We upload an industry-standard design model, and then Collider's software takes over to design a mold for your part. Then Orchid uses continuous DLP to 3D print a hollow shell. That shell is completely smooth with no visible lines. Then we inject off-the-shelf manufacturing materials into that shell. These materials chemically cure to form a solid part. This is a steel metal slurry, but it could easily be anything in our catalog. The process is exactly the same. Once the build cycle is complete, you remove the build platform and dunk it in hot water. That shell material dissolves away, leaving a production quality part. Can we switch to Graham in the live demo? Thank you. Graham has shells that he's been dissolving for about 20 minutes. The shell material that he's washing off is a world first and a patented Collider invention that is critical to our process. Let me show you a few applications. This steel part is an iteration of the video you just saw. It's the shift lever from the pedal on a custom motorcycle. CNCing this part would have taken a week. Collider got it to a green state in a matter of hours. This rubber part is from custom footwear startup Weave. They just finished their wildly successful Kickstarter and needed to see this iteration of this product in a customer-ready material. We saved them from cutting a mold which would have cost thousands. This part retails for $60. And finally, custom prosthetics can cost thousands, so amputees usually buy uncomfortable one-size-fits-most liners. Alongside a national prosthetics company, Collider can change the quality of someone's life with customization. This silicone liner is a perfect fit, and it retails for under $200. Can we go back to the slides? Orchid is 5 to 60 times faster, 3 to 125 times less expensive, and has a potential materials catalog of hundreds. Orchid's process is so simple. You just press a button to start, plug it into the wall, and there's no skilled labor or special ventilation required. When you're ready to kick off a print, you just snap in the materials cartridge, you press go, and our software will handle the rest. Orchid prints at vertical target speeds of 36 centimeters per hour, and our build volume is about the size of 2 shoe boxes, which you can fill with the same parts, with different parts. It's totally up to you. As I'm sure you can tell, Orchid has applications across verticals. We're initially targeting service bureaus and rapid prototyping shops, and then we'll look to companies that can benefit from rapid iteration, like medical and automotive manufacturers. Please go to collidertech.com to sign up to Lisa Beta today. Collider is enabling an entirely new category of manufacturing, and if you are a service bureau or a rapid prototyping shop, we'd like you to have a beta, so please reach out. Thank you.
All right. So judges, do you guys want to try out the parts maybe? Do you want to pass those down? Cool. All right, who has the first question? Devin?
So, are you selling a service or is it actually hardware?
We're leasing this actual machine to customers.
And so what's the business model? What's the price point that you're trying to lease the unit at? And how does it compare to whatever they're doing currently?
Yep, so we're leasing Orchid and we're retailing the catalog of materials that goes into it, like HP's printer ink model.
So you said there was a different process for metals because it's going to be maybe slightly more difficult in the back of a garage to melt down some copper and put it inside the mold. Can you explain how that's going to work and what the different costs are going to be vis-a-vis different materials?
Yeah, absolutely. So actually, the way that we inject the metals is actually not in a molten state. So what we do is we inject a combination of liquid resin and metal powder particles into the shell. Those cure solid inside of the shell just like the plastic and rubber parts do. Then you dissolve away the shell the same way, then it goes into a sintering furnace. That's the extra piece of equipment that you have to work with this technology. That has a price point that we're not quite ready to disclose at this time publicly.
So how much testing have you done with this? How many clients have you worked with?
Yeah, so over the last year, we've been printing parts for customers. So we've printed over 200 parts for customers. 50 of those are paid parts. Some of those were tryout parts for companies that were potentially considering purchasing a beta machine now that we're to that stage.
So all we do is customer feedback. We're trying to continue to improve the machine as we develop it.
How many machines are there right now for lease?
So we just opened up the beta program for leasing, and so there's no actual machines at facilities today, just the machines that are at our facility. We have just a few of these machines that we use to make the parts currently.
We just launched our beta on Monday.
Yeah.
And when you think about the service bureau market, how big a market is that? What % of the machines in that market would you have?
The service bureau market is actually huge. There's 1,500 of them in the US alone, and it's over $1.7 billion. And then if you begin to add the rapid prototyping market on top of it, it's exponentially bigger.
Tell me about the team. Who are you?
So, I'm Graham. No, so I come from a background actually working in the 3D printing industry. I've been working with the technology actually since I was 15. I previously worked for Shapeways, which is the world's largest 3D printing service bureau, as well as working with manufacturers who were looking to adopt additive manufacturing technology, which led to the development of the Orchid and the Khaki.
And there's 5 of us on the team total. My background is in B2B and business and law, and so I've experienced scaling companies.
So kind of what percentage of the time does kind of cheaper 3D printing a good enough substitute for what you guys are doing? How often do you actually need this level of sophistication?
Yes, it's a great question. So typically, 3D printing today is going to be used for prototyping, and that's going to be primarily for fit and form for the most part. And so in that use case, you don't actually require these materials because you're that early in your design iteration. At some stage, though, before you're going to ship 1 million of something, you really need to find out what it's going to be like in the real materials in case there's shrinkage issues, in case there's wear issues. That's where we really get involved in the process. So maybe your first, let's say 1 to 5 kind of iterations, maybe you're going to use that technology, or maybe you're just going to go directly to ours.
But if you look at the service bureau market, which you said was a $1.7 billion market, how much of that is that initial prototyping versus the last step before you actually go to production?
Yeah, so that's also a fantastic question. So actually, some of the biggest service bureaus that we have in America today's biggest business isn't actually 3D printing. It's actually plastic casting. So behind the walls is actually having a lot of silicone mold making, and they're making a lot of parts for those exact customers. So a lot of their business is coming from, for instance, Stratasys Direct is North America's largest plastic casting firm, even though they're ultimately a 3D printing company. So it's a huge portion of their business today.
Just comparing yourself to, originally like 6 or 7 years ago, MakerBot really, made a good penetration into a lot of the rapid development. Obviously, that became part of Stratasys. A lot of these guys are reasonably well integrated already in. As you go in, what is your pitch to not be the first sort of rapid prototyping or 3D type printer, but to be able to replace existing guys that have billion-dollar market caps and will be able to say that they're doing things that can be similar, could potentially be more cost-effective, or that they will have more staying power, or just basically being a gorilla in that space where you're a more interesting, innovative startup?
Yeah, so it's primarily a materials play with those companies, right? And so you're very limited. You can only work within a small spectrum of materials that those companies have developed for their technology, and you have to buy it in the same medium and format that you would, the unique format that they have specified for that particular printer. And so the materials play is really what we're going after here, the ability to work with those traditional manufacturing materials, and that's the selling point. And because plastic casting is such a big part of these companies' business today, that's a really exciting opportunity because it's the exact same materials that they're using inside of their silicone molds for those same customers today.
Now,
Sorry, go ahead.
oh, yeah, what's the threshold at which, so it seems to me like there's like a horizontal slice of business that you're going after. Because at some point if somebody makes 100,000 of something, they're gonna, do tooling and make molds and do their thing. And then at the low end, if somebody's, fooling around at their desk and doing initial prototyping, they might use a 3D printer. So explain to me what point you start and what point you end, like your business ends, in terms of volume, for instance.
Yeah, so that's a fantastic question, and the answer is it depends a little bit on how you're using the technology. So if you're looking for mass customization, for instance, custom footwear, custom prosthetics, things like this, you can use this to make whatever volume you're looking for. We envision a world where you have 50 of our machines and they're your production for your entire custom shoe wear line because you can deliver them in the materials that you need to be a production product for your customers. If you're looking to do kind of, let's say, an identical set of parts and the part's going to be the same every time, it depends a little bit on the size. We put that threshold usually around 2,000, 2,500 parts before it makes sense for you to go out there and cut that steel tool at that point. That does depend on the size of the part. Can be higher with smaller parts.
And have you evaluated the size of this customizable market or done explorations there?
We have. The customization in footwear alone is worth $2 billion. And because it's so incredibly expensive to customize anything, because right now you actually have to cut a multi-$1,000 mold, it just isn't done. It doesn't make sense for me to have a pair of custom shoes or a custom watch band because it's going to cost the company that's selling it to me $10,000 or $15,000. But with this machine and with our technology, you can actually submit a part file to the machine and it's going to cost you the same to make one for me and you at the same time.
Which opens up almost a whole new kind of category of opportunity for a company who wants to do custom goods but maybe couldn't.
Right. I mean, this is something that like Adidas is experimenting with Carbon 3D, right? So you go to Nike and say, we have something, you can use too, right? Is that a real, I'm trying to gauge how much of it your business is leaning on the customization aspect versus just, hey, we've got this thing that can do the same thing you already do.
Sure. So I guess, let me frame that. Well, yeah.
So we're doing the same thing that people are already doing, but dramatically faster and dramatically less expensive because we are directly replacing tooling, which is the current process. And so if we go back to when Collider was just getting started, that's actually kind of what put the seed in Graham's head was all of these manufacturers just kept complaining that tooling was so expensive. And you hear about it with startups also, right? They're developing some sort of new product, and the tooling expense is always a huge portion of getting a hardware company to market. I mean, the same experience exists for a hardware product, and so what we're doing is we're increasing that speed to market by making it so that you don't have to cut a mold, go to China, get that mold back, put that mold in an injection molding machine, do it once, see the part, and think, I need to tweak this.
What's the biggest thing you've learned?
In what category?
Well, in the 100 prototypes that you've built, what's the thing that you thought?
I think one of the biggest takeaways is companies need to see their own parts. So companies aren't going to jump on board with adopting a new technology until they can see it in the exact same part. It's not something that's like their part, it's this file, and it's in this specific material, and we've been able to offer them that. And so I think that was one of the biggest takeaways for me anyway, was learning that that was something that they required in samples, things weren't.
Well, and it's really exciting because a company can come to us and say, I need to see this part in this material because I'm looking for these particular characteristics. And because we're buying off-the-shelf materials and putting them through our process, we have full spec sheets on all of these materials. We can also have companies come to us and say, hey, I actually need this arrangement of qualities that we don't have in our materials catalog. We can go to one of our customers, find a spec sheet, from a material that's been developed over trillions of dollars and decades of research by one of our partners, and test it overnight and then deliver it to you.
How do you think about the business model? I know you don't want to talk about the pricing specifically, but how should we think about the gross margin of the business? And just given it seems like fairly complicated hardware, what's the capital intensity as you start leasing these?
Sure. So this machine is actually deceptively simple. We've designed it in a very modular way so that we're kind of prepared for total meltdown. And our margins take into account a service contract over 3 years, the case of total meltdown, and then replacing parts and making sure ultimately that our customers have an awesome experience. So we've worked that into all of our pricing models.
And is there a gross margin?
There is.
Can you be more specific than there is a gross margin?
We have a very comfortable gross margin that allows us to make sure that the customer's experience over 3 years is awesome.
So let me ask this a slightly different way. I understand this is less expensive if you are looking at the alternative being a $10,000 mold. Mm-hmm. But one of the things you talked about earlier was that someone might want to make 1,000 of X, Y, or Z. My guess is that that would actually not necessarily be less expensive because you're making a good part of your margin on, as you say, the ink, the way that HP did. So where does this become less cost effective?
Yeah, so two things. So one of them is that the materials that we're working with, because they are mass produced and have been for decades and they're off-the-shelf materials, we can actually have a reselling price that's on par with traditional resellers of that material, which gives us an ability to have up to a higher number of parts be cost effective. And again, that kind of comes back to the number that I touted earlier, which is, as you kind of are working with identical parts or duplicate parts, as you said, that are the same over and over again, part of it depends on the design, but we kind of use as a rule of thumb, if it's a 3x3, something in the lower 1,000 range, a couple thousand parts or something of that nature. But with a feasible and visible pathway to making that number higher as we do things like build larger build volume machines.
Mm-hmm. All right, so we're pretty much out of time. So give it up one more time for Collider.
Thank you so much.
Thank